tell us a little bit more about how you're moving into complete modular sensors.
Yeah, indeed, the technology behind is exactly the same. Might be surprising. So even though it's about flow sensing, here we talk about ultrasonic flow sensing. The technology is again time to digital conversion. What we do, we measure the speed of an ultrasonic burst, in whether it travels with or against the flow, and the time difference is proportional to the flow rate. This is exactly what we want to measure. The amazing thing is that here, in the end, we look at picosecond resolution again. In addition, this is typically battery-driven systems, so we need to do this with a very low power consumption. And this is the perfect application for a TDC. And that's how we come into this market. So, and we started indeed with the standard front ends, so offering a solution for all those people that build their own flow sensors, their own tubes, and applying piezoelectronic transducers. But now we started really to have the first own module that offers a complete solution where the people can mount it into their application and read out the volume.
Now, is this flow sensor focused on liquids or gases or both?
This one is on liquids. We initially thought, of course, only about water, but we can use it also for beverages, cooling through liquids. So this is applicable to many liquids that you can think about.
Yeah.
But the applications that we see is water purifiers, water dispensers, filter applications, then also the sanitary equipment, smart water taps, smart toilets. There it's more about then not measuring the flow rate, but detecting leaks. Because with this ultrasonic technology, we can measure very low flow rates. We even can detect dropping waters, taps, I would say. So this is a nice driver for this application.
And so what sort of span of flow rates would that encompass?
So with the current device, the UFM 01, so we cover a range from 60 liters per hour to 2,000 liters per hour, so typically a household application. But we want to build a complete family around that, so with bigger diameters, 1 inch, 1.5 inch, but also smaller diameters. Mm-hmm. So in the end, with the technology itself, we could cover a much higher range. So it's just depending on the diameter of the modules that you will then offer.
Yeah. I guess many people would also be a little bit concerned about the robustness of having an electronic system so close to a fluid with the ultrasound as well. Do they come into contact?
No, that's the great advantage of this technology. The UFM 01 is a static system, no moving parts, and the transducers have no contact with the liquids. So that's why it's so suitable for beverages, for example, for food applications. Yeah. And this non-contact principle also gives us a long lifetime, so an easy maintenance of the system. So there are no rotating parts, like in a turbine meter, for example, we have the propeller rotating, which got stuck after a few years. With ultrasonic technology, you can run for many, many years. Yeah. In smart water meters, typically we talk about 20 years of operation.
Yeah, of course, yeah. Super. Well, thanks ever so much for the update on the ScioSense